Okay, I have here on the board today another interesting integral from the UNSW Integration Bee 2023. This was problem 8. We have the integral from minus infinity to infinity, x squared minus 1 over x squared plus 1 all squared dx. Okay, so to get started with this, there's something jumping out to me, just the similarity between x squared minus 1 and x squared plus 1. So what I want to do is I actually want to force that to be an x squared plus 1 in order to get cancellation, but I can't change it. So what I'll do is subtract off a 2. So we still have minus 1 here, and now it's the same thing. But then with this minus 2, what I'll do is I'll actually split this into two separate integrals, one that will get the cancellation, and then the second one will have a minus 2 that I can bring out front. And now that we have this split up, what I can do is the cancellation, so that's going to cancel with one of these. So then now we just have dx over x squared plus 1 here. So this is a really common integral. This is one that I've done a few times, I think, as an indefinite integral, so it shouldn't be too bad. Now this first one, this is actually just our integral of arctan with dx over x squared plus 1. So let's just do that. This is going to be arctan of x, and we're just going to evaluate that from minus infinity to infinity. And because I think this one's more complicated, let's just finish this one first and we'll bring the answer forward. So if I evaluate arctan, of course, this is going to be a limit as x is approaching infinity. Well, this first part's going to be pi over 2. And then for the second part, if we look at it when x is approaching minus infinity, this is going to be minus pi over 2. Of course, minus times minus gives me a plus. We add pi over 2 and pi over 2, it's just pi. So with this first piece, I'm just gonna take this and label this pi, and then we'll focus on our second integral. Okay, for this one, I think I know 2 or 3 ways to do it, but I think in this case, what I'm gonna do is go with the trig substitution. So for my x value, I'm just gonna call this tan of t. We'll take a derivative, so then dx is gonna be secant squared t dt. Then we'll bring this other stuff down and we'll go ahead with the substitution. Looking at when x is infinity, then tan is going to be pi over 2. Then looking when x is minus infinity, tan is going to be minus pi over 2. Then we have our dx value right here. So this is going to be secant squared t dt. And then here we're going to have tan squared t plus 1 all squared. Then before I continue, one thing I notice here is this is definitely an even function. So how do I know this is an even function? Well, secant's an even function, but has a cosine in it. Sine's odd because it's squared, and then everything's squared again. So this is all even. And then what that allows me to do when we have symmetric bounds, I can remove the lower bound, write this as a 0, and bring a 2 out front. But since we have 2 times 2, I'm just going to write this as a 4. Next, for tan squared t plus 1, I'm going to use the identity that this is secant squared t. But then we have secant squared t squared, so this is going to actually become secant to the 4th t. So let me just kind of make it clear what's happening. In the numerator, we've got secant squared t. And then here in the denominator, we've got secant to the 4th t. I can cancel 2 of these with 2 of these. And so we have secant squared in the denominator. But secant squared is the same thing as 1 over cosine squared. So essentially what we end up with is this whole expression is going to be just cosine squared of t. So at this point, our whole integral is just cosine squared of t. But for this thing here, what I'll do is we'll just use the power reduction on this. So I can write this as 1/2 times 1 plus cosine of 2t, just doubling the angle. But then what I'll do is multiply this 4 times 1/2, and that's just going to give me a 2 here. But now we can just go ahead and integrate this thing because we've got everything set up nice. So integral of 1, that's just going to give me t. Integral of cosine 2t, that's just going to be sine of 2t. But then we need to bring the 2 out in the denominator, so I'll write this as 1/2, and we just need to evaluate this from 0 to pi over 2. Now what you'll notice here is when you plug in 0 to t, that's just going to be 0. Plugging 0 in here, you're going to have sine of 0, that's also 0. So I just need to evaluate pi over 2. So we'll just copy down what we have here. We have pi minus 2, and then plugging in pi over 2 everywhere, we're going to have pi over 2 in here for the t, plus 1/2 sine 2 times pi over 2 is just pi, but sine of pi is 0, so that piece goes away, and we're just going to have this pi over 2. So distributing this in here, we're going to have our pi out front, but then minus 2 times pi over 2 is just going to be minus pi, but then pi minus pi, that gives us our final solution of just 0. So good problem today. We'll stop it there. Thanks everyone for watching. Have a good day.